Subtracting signed mixed numbers. If we're working with signed mixed numbers, then we first need to convert them into addition problems. So I see negative 3 1/2 minus negative 6 2/3. So I keep my negative 3 1/2. Subtraction becomes addition, and the negative 6 2/3 becomes positive 6 2/3. Now I see that I still have a negative, so I'm going to convert these to improper fractions. So 3 times 2 is 6, plus 1 is 7. So I get negative 7 halves, because remember my 3 1/2 was negative, plus 6 times 3 is 18, plus 2 is 20. So we get 20 thirds. Now I need a common denominator, and the common denominator between 2 and 3 is going to be 6. So 2 times 3 is 6, and 3 times 2 is 6. Negative 7 times 3 is negative 21 over 6, plus 20 times 2 is 40 over 3 times 2 is 6. Now that I have a common denominator, I know in my answer the common denominator stays, and I've got negative 21 plus 40. So we're adding different signed numbers, so I need to subtract and keep the sign of the number with the larger magnitude. 40 minus 21 will give me 19. That's my magnitude. Now I look at 40 and it's the larger number and it's positive. So my answer will be positive. So right now I have positive 19 over 6. Well, I need to know how many times 6 goes into 19 to know how many whole units I have. Well, I know that 6 times 3 is 18. So it will definitely go in 3 times. To get from 18 to 19, I need one more. So I get 3 1/6. In example number 2, the first thing I do, since I've got a negative here, is change this into its equivalent addition problem. So I get 3 1/2, the subtraction becomes addition, and the negative 2 1/4 becomes positive 2 1/4. What I can see I have now is 3 1/2 plus 2 1/4. And these are both positive, so there's no need to turn these into improper fractions. The common denominator between 2 and 4 is 4, because 2 times 2 is 4. So that gives me 3 and 1 times 2 is 2, over 2 times 2 is 4, plus 2 1/4. Now I can add the whole numbers and the fractions separately. So 3 plus 2 is 5. And then 2/4 plus 1/4 gives me 3/4. 3/4 is not reducible, so 5 3/4 is my final answer. In example 3, I've got negative 5 minus negative 7 5/6. So the first thing I'm going to do is turn this into its equivalent addition problem. So I've got my negative 5. Subtraction becomes addition, and the negative 7 5/6 becomes positive 7 5/6. Well, I've definitely got a negative left in my problem, so I'm going to want to convert these to improper fractions. The negative 5 is a whole number, so I could rewrite that as negative 5 over 1 plus. The 7 5/6 is 7 times 6 is 42, and 42 plus 5 is going to give me 47. Alright, so now I need a common denominator, and the common denominator between 1 and 6 is 6. So I have to multiply the 1 by 6 and the negative 5 by 6. That is going to give me negative 5 times 6 is negative 30 over 6 plus 47 over 6. Common denominator of 6 stays. Negative 30 plus 47. They're different signs, so I need to subtract and keep the sign of the larger number. 47 minus 30 is 17. The 47 is larger and it's positive, so my answer will be positive. So far I have 17 over 6. 17 over 6 is definitely improper because the numerator of 17 is larger than the denominator of 6. So I want to know how many times will 6 go into 17. So I can either say, well, 6 times 2 is 12, so it will go in twice. 6 times 3, that would give me 18. And 18 is larger than 17, so I can't use that one. So it's going to go in twice. Remember, 6 times 2 is 12. So now I need to know how many more 6 do I need to get from 12 to 17. And the difference between 12 and 17 is 5. So I get 2 and 5/6.